my dear champions, I welcome you all to day 14 of scoring 99% in 99 days. Today we would be having the mock test 2 for our 10 series, and over here as you can see there are two chapters which are included. One is life processes and the other one is light. In light we'll be talking about reflection. So the questions would be around that and it will be done in parts by me and Soumik sir. So the first part is done by me where I'll be talking about the chapter that is life processes. I would be solving certain questions. How many of them? Let's see. So there will be 6 MCQ questions, each of 1 mark. There will be 2 short answer questions, that is of 2 marks, and there will be 2 short answer question of 3 marks, making it a total of 6 over here. So 3 into 2, 6, right? Now long answer type, there will be 1 5-marker question and there will be 1 case study based question. Total how many marks are you going to get? 25 marks. So after the end of the paper, if you're religiously doing the paper with me, then you have to tell me how many marks you have scored in the comment section. Works? Cool? And even if you do not do, it's okay if you're not able to find the answers for that. If you're just trying to understand the answers with me, I'm totally fine with that, but give your best in understanding as well. So let's get started. Let's solve the first question that we have over here. Assertion says the rate of breathing in aquatic organism is much faster than in terrestrial organism. So do you think the rate of breathing in aquatic organism is actually faster than terrestrial organism? The actual thing is yes, they are actually faster, but the reason we have to find for that, right? So the reason that they have said is that the amount of oxygen dissolved in water is very high as compared to the amount of oxygen in air. So they are saying the amount of oxygen which is in water, it is way high than the amount of oxygen that is there in air. Is that true? It is absolutely wrong. It is what? Absolutely wrong. Okay, the reason why aquatic organisms, they breathe faster is that the amount of dissolved oxygen in water, instead of being high, it is less, my dear children. So every time, for example, there is a fish, okay, every time the fish takes in the water, it is having only a very little amount of oxygen. So every time it has to take in more amount of water, that means it has to breathe faster so as to take in more and more oxygen. So this is the actual reason. The reason should have been the amount of oxygen dissolved in water is very less as compared to the amount of oxygen in air. If that was the reason, it would have been correct. But over here I see the assertion is the only thing that is correct. So assertion is true, but the reason is false, my dear children. This becomes the answer. This is a previous year question. All the questions that I am solving today are previous year questions. Okay. Next question. Which of the following statement is true about human heart? Let's see about human heart. So, right atrium receives oxygenated blood from lungs through pulmonary artery. So, before going into that, let me just give you a brief. Over here, these are 2 atrium. One is left, this is right. These are 2 ventricles. One is, oh my god, one is right and the other one is always wrong. Now this one is the next ventricle that we are having over here. So we have our lungs and we have our body parts. So what usually happens is the lungs is a place where we oxygenate our blood. Okay, oxygenated blood will be going to the left atrium. Bring in oxygen. So that is how you can remember it. So it is what? Oxygenated blood. Then this goes over here. Then this goes to the rest of the body. So this side of the heart, left side, is always carrying what? Oxygenated blood. Now the oxygen is given to the body parts. What will they give back as a return gift? Carbon dioxide. So now the blood is rich in deoxygenated blood. So I'll say it is rich in carbon dioxide. So it is deoxygenated blood. This goes to the right atrium first, then right ventricle, then it goes back to the lungs to get oxygenated. So this side of the heart, it is always deoxygenated. Now let's begin to read the option. So right atrium receives oxygenated blood from the lungs, never. Right side does not get oxygenated blood. Left atrium transfers oxygenated blood. Left atrium transfers oxygenated blood to the left ventricle, which sends it to the various body parts. Actually true. So let's keep it. Next, right atrium receives deoxygenated blood through vena cava from upper and lower body. Right atrium receives deoxygenated blood through what? Vena cava. Vena cava is a vein. Yes, it is receiving with the help of vena cava only. And vena cava, there are 2. There is superior vena cava which collects from upper body and inferior vena cava which collects from lower body. So we have superior and inferior vena cava. So they are going to collect and going to give it to the right atrium. So that is also correct. Next, left atrium transfers oxygenated blood to your aorta which sends to different parts of the body. So left atrium does not transfer blood directly to aorta. This is aorta. This is aorta which carries the blood after the left ventricle. It is not coming over here. So this is wrong. So what has true, children? B and C becomes true. So the answer becomes this. Got it? Easy. Next, in human respiratory system, when a person breathes in, the position of ribs and diaphragm will be. So when I breathe in, wait, here the ribs have basically lifted. The lips have lifted. Ribs are basically lifted. Apart from that, one more thing is happening. So this is a human body, and they have something that separates the thoracic cavity, that is where your heart and lungs and everything is, from the abdominal region, and thus is known as a diaphragm. So you only think when you want more space over here, when you want more air to enter over here. So basically this diaphragm, which is like this is a dome shaped diaphragm. What is it? It is dome shaped. This diaphragm should be coming down, which is going to form a flattened diaphragm. So when I breathe in, I want more space. At that point of time, I want flattened diaphragm and not the dome shaped diaphragm. And I should have lifted ribs, not relaxed ribs. The ribs should be lifted up. So lifted ribs and curved dome shaped diaphragm, no. Lifted ribs and flattened diaphragm, yes. This is what I want. And when does the diaphragm gets flattened? You should be knowing that also. It flattens when it is contracting. This is contraction. Usually we think that it is relaxing. No. Diaphragm, when it contracts, that's when it becomes flat. When it relaxes, that's when it becomes dome shaped. So always remember like this. When we are also we are relaxing, we are all like this, right? So this is also like this. I hope you got the answer. Next. Tooth decay begins at the pH of what? So tooth decay will happen when it is too much acidic. Okay, when it is too much acidic. So over here, the acidic pH that I can clearly see is this one, 5.1. So below 5.5, I will say it's very much acidic. Okay, so I hope you know this pH scale. 1 to 7, the 7 is the neutral thing. So 1 to 7, it is acidic. Over here, when you go, it becomes more acidic. From there to there, it is alkaline or basic. Here to here you go, it becomes more basic, and this is the neutral thing. So 5.1 is over here, okay, somewhere over, not over here, but I hope you got it. Basically it is moving towards this particular direction, right? So it will be acidic. This is the answer. Next, in human beings, when process of digestion is completed, the proteins, carbohydrates and the fats are respectively finally converted to. So proteins are made up of amino acids. So proteins, when they are broken down, they will be forming amino acids. Okay. Carbohydrates, when they are going to break down, they are going to form glucose, the smallest sugar molecule that we have. What is it? Glucose. And then fats, when they are broken down, they break down to fatty acid and glycerol. Please write it somewhere. Okay. Proteins, when they are broken down, it breaks down to amino acid. Carbs, when they break down, they break down to glucose. Fats, when they break down to fatty acid plus glycerol. So this should be your answer. Amino acid, glucose and fatty acids. Amino acid, glucose, fatty acids and glycerol. So this is more correct. If you have stopped by seeing fatty acid over here and you have given a correct answer for that, then it is wrong. So this is the answer, fatty acid plus glycerol. Glucose, no. You cannot break proteins into glucose. So basically this is the answer. Next question. Assertion says, in the human heart, ventricles have thicker muscular walls than atria. Is it so? Do you think that ventricles will have thicker muscular walls? Yes, it is so. Why? Because ventricles, no. From atria, blood passes to the ventricles. The ventricles have to pump the blood to the next place. So it has to be very thick walled. Otherwise, this pumping won't be happening. Okay, so that is true. Why? The reason becomes ventricles have to pump the blood into various organs. That is true. So assertion and reason both are true, and the reason is explaining the assertion as well. So I'll say both assertion and reason are true, and the reason is the correct explanation of what? The assertion. Works? Okay. So with this, we have completed the MCQ. Let's go on to the 2 marker type of questions. So photosynthesis takes place in the leaves and the food prepared by it reaches other parts of the plant. Name the process involved and explain it. So photosynthesis, you know, it takes place in leaves, and the food that is there, it goes to the other parts of the plant with the process of translocation. what do you call it? Translocation. And translocation basically happens with the help of a vascular tissue which is known as phloem, my dear children, where basically, for example, in leaf the food is being made up. Okay, in the leaf food is being made up. Okay, what happens? They are made up of cells, and these cells are connected to form these cells. Suppose this is a cell, this is another cell, and this is your phloem tissue. And the food is made up over here. The food will be moving towards the phloem tissue like this. Okay, the phloem tissue is made up of two very important cells. One is sieve tube cell and the other one is companion cell. One is what, children? Sieve tube cell, and other one is what? Companion cell. So over here what happens is that the food that is being made in the leaves, whatever area of the leaf, palisade, mesophyll, whatever cell, it is being transported to the companion cell. From here it is transported over here in the phloem. This is known as loading. This is known as loading. Okay, and in what format is the food being transported, my dear children? In the form of sucrose. Actually now in the plant the food is made in the form of glucose, but glucose is kind of reactive. If it moves around it will react with lot of things. So it is converted to sucrose first. Okay, sucrose is a non-reducing sugar. It does not get reduced. It does not undergo so many reactions over there. So sucrose is basically transferred from here to the companion cells, from the companion cell to the phloem tube, sieve tube cell. Now what will happen? Basically, when here you have too much amount of solute, this sucrose is going to act like a solute, right? So parallelly you have xylem tissue also. Xylem tissue will be taking and giving the water to that particular area, because water moves from a region of higher concentration to a region of lower concentration. Now over here you have sucrose, you have water, you have everything. The pressure increases. The pressure here increases, and now this area, whatever things you have over here, what do you call it? You call it phloem sap. The food plus the water, everything, you call it phloem sap. Phloem sap will be moving to the area of low pressure, for example down. So it will be moving down, and then here also you will be having companion cell and some other cell. So from here the food is transferred to the companion cell and then to the other cell where it can be stored or it can be used. This is known as unloading. This is known as unloading. Okay, so food moves there. What happens to the water? The water will be moving back over here. Now if you want a detailed explanation of this, you can watch the video that I made for you in the concepts. Okay, you will get the detailed explanation. It's a 2-marker question, so how you have to explain? You can explain like this. The process involved is known as translocation, and in this process, who is transporting things? It is transported via the phloem. What happens? First, loading of the food. The food, that is sucrose, enters the phloem from the companion cells. Movement. Water from the xylem pushes the phloem sap through the phloem tubes to all parts of the plant. Unloading. The sugar moves out of the required place for use and storage. This is how you can frame your answer. Please underline things. Loading, unloading, and the place from where it gets loaded, you call it as source, and the place where everything is given off, it is known as sink. Works? Now next question. 2 test tubes A and B are taken, each containing 1 ml of starch solution. So let's take. This is test tube A and this is test tube B. What are you taking? 1 ml of starch solution. Here also you have starch solution. Now add 1 ml of saliva to test tube A. In this I have added saliva also. Okay, now what happens? And leave both the test tubes undisturbed for a few minutes. Now add a few drops of iodine solution. Let's put iodine solution. Next thing that I am going to put is iodine over here and over here. In this test tube I didn't put saliva, okay? I have just put iodine. Which one of the 2 test tubes should change in the color? Which one do you think will be showing change in the color? I will say it is B. Why, ma'am? Why it is B? Because you have starch, and in the presence of starch, when starch and iodine they come together, what color does it give? A blue black color. So why is not color changing happening over here, ma'am? Because you have put saliva, and saliva has what? Salivary Amylase, that is the enzyme, and salivary amylase is going to act on starch, break it into what? Maltose, which is why you won't be finding starch over here. When the iodine comes in contact with it, it will be just normal color. There won't be any color change. Now, write the changed color observed in this test tube. It is blue-black color. What can we conclude from this activity? We can conclude that saliva has some enzyme that will break down starch, which is why it gives a negative iodine test. Whereas over here, it will give a positive iodine test. Works? So this is how you can frame your answer. Test tube B shows change in color. The solution turns blue-black due to the reaction between iodine and starch. Please write in points. Okay, so over here you saw this was the first part of the question. So you answer the first part, then the next part. Write the changed color observed in this test tube. Don't go write this first and then this. You would miss the questions. That is the use. Now write B and write the answer for this as well. And underline the important things. Works? Next is a 3-marker type of question. Why is respiratory pigment needed in multicellular organism with large body size? Why do you think you need a respiratory pigment? Is diffusion not alone enough to transport things around? No, because we are complex organisms, children. So diffusion cannot maintain this thing. For example, the outer layers of cells can take things via diffusion. What about the cells inside? It's a very slow process. So basically, I need a respiratory pigment which will be carrying the gases around my body. So what is respiratory pigment in my body? It is hemoglobin. So you have to write about that also. So why is respiratory pigment needed in the body? Why? Because I need to transport a lot of gases throughout, and we are what? Complex organisms with larger body size. Works? Let's see the first part of the question and then we'll go to the second part of the question, okay? A respiratory pigment like hemoglobin is needed in multicellular organism to efficiently transport oxygen to all cells, as simple diffusion is insufficient for the larger body size and complex structures. Now, next part of the question, give reason for the following. Write A and write the answer. Rings of cartilage are present in the throat. Why do you think rings of cartilage are present? So that, for example, when I'm not breathing, I don't want trachea. I don't want the trachea to collapse. I want it to stay in that particular structure itself, which is why I have rings of cartilage. It is rings of cartilage, not of bones. Please remember that. It's rings of cartilage. Next thing, lungs always contain a residual volume of air. So for example, I am breathing out. In my maximum potential, there will be some amount of air still left in my lungs, and this is known as residual volume of air. Why do you think it is needed? Again, so that my lungs and everything does not collapse, and I need it. My cells are needing it. So obviously, I should be having some residual volume of air. Otherwise, I would be dying off, right? So that is the reason. Now, diaphragm flattens and ribs are lifted when we breathe in. So why do you think diaphragm flattens and the ribs get lifted up? Because we need more space in the thoracic cavity so that the air can be taken in. More air can be taken in. That is the reason. Walls of the alveoli contain an extensive network of blood vessels. So if you see the alveoli, if this is the alveoli, it has so many blood vessels surrounding it. Why so? Because alveoli is a place where maximum exchange of gases takes place. So oxygen coming over here, CO2, everything what's there in the blood has to, the CO2 in the blood has to go into the alveoli, the oxygen in the alveoli has to go into the blood. So this is where maximum exchange of gases takes place. This is why walls of the alveoli contain an extensive network of what, children? Blood vessels. So this is exactly what is written over here. Rings of cartilage in the throat prevent the trachea from collapsing, ensuring an open airway for breathing. Residual air volumes prevents alveoli from collapsing and allow continuous exchange of gases even between breaths. Okay, even between breaths, I want things to exchange my gases and everything, my body has to work. Diaphragm flattens and ribs lift off during inhalation to increase the chest cavity volume, that is thoracic cavity's volume, reducing the pressure and drawing air into the lungs. I want the pressure to reduce so that more air can come in. Alveoli walls have blood vessels for efficient gas exchange, allowing oxygen to diffuse into the blood and carbon dioxide to diffuse out as well. Works. So this is why I need it. Cool. Now, next question. Give reason for the following. Again, alveoli in the lungs are richly supplied with blood capillaries. This is the exact thing that we answered as of now. So I don't think we need to answer it again. Okay. Next thing. Respiratory pigment in the blood takes up oxygen and not carbon dioxide. Respiratory pigment in the blood, why does it take up oxygen? That means you are talking about hemoglobin, my dear children. why do you think hemoglobin is taking up oxygen and not CO2? It is taking up oxygen. Why? Because, my champions, hemoglobin has higher affinity. Has higher affinity for oxygen rather than carbon dioxide, which is why it is taking up oxygen and not carbon dioxide. Okay? Now, whereas when you talk about carbon dioxide is more soluble in fluid, or basically water, which is why it is transported via hemoglobin also, but it has lesser affinity to hemoglobin. Rather than that, most amount of it is transferred via the plasma. So plasma is a fluid in that it can easily get dissolved and it can move around. Okay? Now, during anaerobic respiration, a 3-carbon molecule is formed as an end product instead of CO2 in human beings. So basically, in anaerobic respiration, that means when oxygen is not there, at that point of time respiration has to happen. Over here, the glucose, which is a 6-carbon compound, breaks down to pyruvate, which is what? A 3-carbon compound. Now in the case of, it breaks down to 2 molecules of pyruvate, each of 3 carbons. Okay. Now in the case of normal respiration, that is aerobic respiration, this pyruvate will get inside the mitochondria, do the whole process and give CO2 plus H2O plus energy. But in the case of anaerobic respiration, where there is no oxygen, at this point of time pyruvate will be forming what? Lactic acid plus energy. So that is the question. During anaerobic respiration, a 3-carbon molecule is formed as an end product instead of CO2 in human beings. What is the reason? Because it is basically not finding mitochondria for doing aerobic respiration. So how we can frame the answer? During anaerobic respiration is formed as an end product instead of CO2 in human beings. Why? Because in anaerobic respiration, pyruvate is produced from glucose via glycolysis. Instead, being further broken down into carbon dioxide, pyruvate is converted into what? Lactic acid. So instead of getting inside the mitochondria, it is basically not getting inside the mitochondria, it stays in the cytoplasm and breaks into another 3-carbon compound, which is known as lactic acid in the muscles. So here, why it happens? Because oxygen is not available, my dear children. Rest all the things is just as I explained. You just have to underline the things and write in points. Okay, please make sure you are writing the answer in points. It is very much important. Works. Next question. Design an experiment to demonstrate. This is a 5-mark question. Okay. Design an experiment to demonstrate that carbon dioxide is essential for photosynthesis. Write the observation and conclusion of the experiment. So over here, this is the experiment that you can do. What you can do is, you can take a plant, you can take another plant, cover it with a glass jar, which is transparent. Okay, and now put a small bowl over here and put potassium hydroxide in there. What are you putting, children? You are going to put potassium hydroxide in over here. Now you will tell what's the use of this. I'll tell you. So in the daytime, what happens? There is sun. So basically sunlight falls on both. So you expect photosynthesis to happen because sunlight is there, you already provided water and everything. So photosynthesis should generally happen. Here, if you see, if I close it also, what happens is that the plant is undergoing respiration. That is, oxygen is being utilized for the breakdown of food to give carbon dioxide. This carbon dioxide is again utilized by the plant for giving out oxygen. This oxygen is again utilized for respiration, and the whole process goes on. That is a natural thing that happens. So this plant is kind of healthy, it stays there. But what about this plant? If I am providing water also, okay, water should be an important thing over there. But over here, okay, initially the plant was respiring, it gave out carbon dioxide. This carbon dioxide, instead of going into the plant for the photosynthesis process, it is being absorbed by something which is known as KOH. Potassium hydroxide has the affinity to carbon dioxide, it absorbs it. Now when it absorbs, do you think carbon dioxide is there? No. Now if carbon dioxide is not there, my dear children, do you think that the whole process can happen? No. Hence photosynthesis would not be happening. So this is an experiment to show that carbon dioxide is very much important. So observation for this particular experiment will be what? Basically, you would not be finding photosynthesis happening in glass jar A, where there is potassium hydroxide kept. Okay, and what is the conclusion? And why it is happening so? Because potassium hydroxide is absorbing the carbon dioxide. And conclusion is that carbon dioxide is a very important, raw material needed for photosynthesis, without which photosynthesis cannot happen. Yes? So this is the first part of the question. Next, in the experimental setup shown above in diagram, this atmospheric air is being passed into the lime water with a syringe, while in diagram 2 air is being exhaled into lime water. So over here atmospheric air is being put, over here someone is blowing the air into the lime water. The time taken for the lime water to turn milky in both the test tube is different. In both the test tube it will turn milky, but it takes lot more time over here. But over here it is really fast. Why is it so? Why is the man who is blowing air into this, why this particular test tube is turning milky really fast? Because the lime water, children, what do you call it? You say it is CaOH twice. That is calcium hydroxide. This is lime water. Now when you are making it react with CO2, what is it giving? CaCO3, which is what? Calcium carbonate. It is what? Calcium carbonate. Apart from that, you are also giving H2O. So this is what is turning the lime water milky. Now since you're breathing out carbon dioxide, this is why this is happening. So give reason. The reason is this thing, that when we are respiring, basically when we are breathing out, we are giving carbon dioxide, which is making the lime water milky, as it is going to form CaCO3, calcium carbonate. Okay, this is the reason. Now draw the diagram of an open stomatal pore and label guard cells and chloroplast. So over here you have the stomatal pore which is open. I can draw it for you as well. So this is going to be the, actually I took so many classes today, which is why I do not have too much energy, but children, I can do this for you. So over here I have two guard cells. This is a guard cell, this is also a guard cell. The guard cell will have its own nucleus and all. Okay, apart from that it will have its own chloroplast as well. I am making mitochondria instead of chloroplast. What, ma'am? So let's make it in green. This is the chloroplast which is there. Here also it will have chloroplast. Apart from that, it has a very big vacuole also. Very big vacuole which stores a lot of things. Okay, so I hope it is clear. And this is this area that you see over here. This becomes the stomatal pore. Right? This is exactly what is given over here. Cool. And now one more part of this question is there, which is mention two functions performed by stomata. What does a stomata do? Stomata helps in exchange of gases. When it opens, it helps in exchange of gases, and it also allows transpiration to happen. Now if transpiration is happening, it is losing water, and while plant is losing water, it is able to take the water from down also. So it creates a transpirational pull which allows water to be transported to each and every part of the plant, and also basically it helps in regulation of temperature. When evaporation is happening, you're regulating the plant's temperature also. So I'll say it's there for exchange of gases and for regulating temperature, or for transpiration to happen, or for, if you want more step, transpirational, to create what? To create transpirational pull as well. So many reasons. Works? So the CaOH2 answer is like this. You can read it, okay, whenever you're free. Next, and the last question that we have, this case study based question. Kidneys are vital organs for survival. Several factors like infections, injury, or restricted blood flow to kidneys reduce the activity of kidney. This leads to accumulation of poisonous waste in the body, which can even lead to death. In case of kidney failure, an artificial kidney can be used. What do you call this? Hemodialysis. An artificial kidney is a device to remove waste products from the blood through dialysis. Okay. First, name the artery that brings oxygenated blood to the kidney. So, if this is the kidney, the artery which is going to bring the blood will be known as renal artery. Okay, what is it known as? It is known as renal artery, my champions. Now, Name the cluster the thin walled blood capillaries present in the Bowman's capsule. So what is Bowman's capsule? If you see in the structure of a nephron, it looks somewhat like this, where this is the Bowman's capsule, and then there is proximal convoluted tubule, which is like this, then there is Henle's loop, then there is distal convoluted tubule like this, and then it is attached to a collecting tube. Okay, so over here the renal artery, it branches off into so many small efferent arterioles like this. Okay, what do you call it? Efferent arteriole. Now the efferent arteriole will be breaking down again. So usually what happens, arteries break down into arterioles, arterioles into capillaries, and then capillaries form venules, and then venules form vein. But over here this artery is going to break open into different parts, and again it will form artery only. And this arteriole only, which is known as efferent. One is known as efferent starting with A, other one is known as efferent. So this blood capillaries that is being formed, name the cluster, which you call as what? Glomerulus. What do you call it? You call it glomerulus. Fine? Works. Now, in human excretory system, name the organ which stores urine. Is this organ under hormonal control or nervous control? So what is that thing that stores the urine? What do you think? Okay, just give me a second. So if this is the kidney, there are two ureter over here. Okay, what is this? This is ureter, this is urinary bladder, and this is urethra. Okay, so basically the ureter is allowing the urine to get stored over here, which is known as the urinary bladder. Works? So urinary bladder is not under hormonal control, it is under control of the nervous system. Okay, it is controlled by the nervous system. So it is kind of involuntary in some ways and voluntary also. Sometimes we can hold our urine because we are in hold of one sphincter muscle which is over there, but there is another thing that is controlled by our brain, totally by our brain itself. It is not under our voluntary control, but anyways it's under what? Nervous control. Works? Okay. Now the next thing, list two major steps involved in the formation of urine and state in brief about their functions. So two major steps that I would like to include is, let's see. So over here again, so this is the nephron, my dear children. Over here it will be forming loop of Henle like this. And this is the collecting duct. So basically what happens is that the blood capillaries over here, this is afferent arteriole, and it will gush the blood and bring it. So the smaller particles which can easily move through the capillaries, they will be moving down over here, and this process is known as glomerular filtration. Okay, where things are getting moved really fast. Okay, what are things, children? It is urea, what we have to remove from our body, then also glucose, then amino acids as well, then water and some ions. So apart from urea, we might be needing the other things back. So for that, we have the next step happening that I will tell you. So this is what this region that you see over here, it is known as proximal as in it is near, convoluted as in it is coiled, and tubule as in it is a form of tube. So proximal convoluted tubule, basically what happens is that these ions and everything comes over here. And now if you want them back, apart from urea, if you want other things back, the blood capillaries will be surrounding the whole nephron, and while this process happens of surrounding things, ions and everything will be moving from here to there. So ions will be moving from the proximal convoluted tubule back to what? The capillaries which are surrounding it. Okay, and this process is known as what? It is known as selective reabsorption. So selectively I am taking the important things back. What my body needs, I am taking them back. This is known as selective reabsorption. Now the capillaries around again surround things, and later it will be over here. Now for example, in our body certain ions are taken back, but we do not need it. We want to put it back into the urine and lose it. So at this point of time, the body is given one more chance, or the nephron basically give one more chance to the blood vessels. So this point of time, the things which are not needed are again given back to what? The nephron. Which part of the nephron? Basically it is known as distal convoluted tubule. So again things are given back. What are the things? Probably it could be ions, or it could be something else. For example, my blood glucose level went high very fast. So this point of time I want to give back the glucose. So this process is known as tubular secretion. So basically I have two very important things. One is selective reabsorption and the other one is tubular secretion. Selective reabsorption means I am selectively taking things. So this is important. I am able to selectively take things in. Tubular secretion as in whatever is not needed by body, I am giving it back. So that is the other important process that is happening over here. So with this we have completed all the questions. Okay. And I want to just tell you one more thing, that is, if you are someone who is interested in finding out about your career options, then we are here for you. We have Diksha's Scholastic Aptitude Test, where there will be a 60-minute lecture. On the basis of the lecture, there will be an aptitude test, and on the basis of your marks, you will be having a one-on-one counseling, and the guide would be telling you what stream could be the best for you. So if you are someone who is interested in that, you can click on the link which is given in the description box. Works. And now from here on, Samik sir will be handling physics, and we'll be solving all the questions given in the mock test. So see you there. Bye bye children. Take care.
Hello everyone. So Jasmine ma'am has already discussed question number 1 till question number 12. So I am going to discuss the remaining question number 13 till question number 24, which is obviously based on the chapter light and from the concept of reflection and spherical mirrors that I have already taken the class. Also a bonus revision class was taken. So I hope you have scored well during this exam. In fact, if you have not done so, I am going to explain all the questions, and during our PYQ sessions when this chapter is completely over, I hope that discussion will help you, because there we are going to discuss all the questions from this chapter. Now what are all the questions that is going to be there? Question number 13 till question number 18 is obviously 1 mark MCQ, 6 MCQs are there. Question number 19 till question number 20 are 2 mark questions, 2 questions, 4 marks is there. 21 to 22, 3 marker questions, 2 questions you have to answer, so again 6 marks is there. Question number 23 is a long answer type question, that is 5 marks, and question number 24 is a case study based question, 4 marks. So there are total 25 marks question in this question paper. So let's start with the MCQs. Okay, a ray of light is incident on a plane mirror at an angle of incidence 45 degree. The deviation in the ray produced by the mirror. So we have already learned that the angle of deviation is given by 180 degree minus 2y. Right here I is given as 45 degrees. So 180 degree minus 2 times 45 degrees. So it will be 180 degree minus 90 degrees, that is 90 degrees. Okay, so this is the answer. So correct answer is option B. Okay, next question, question number 14, assertion and reason based question. What is the assertion? The incident ray, the reflected ray, and the normal drawn at the point of incidence all lie on the same plane. Obviously the assertion is correct. So we can see this is the first law of reflection, so this statement is definitely correct. Second reason, as a reason it is given that law of reflection is not valid for rough surfaces, which is not correct. Okay, a law of reflection is valid for all type of surfaces. Okay, so it is not correct. So we can see that A is correct, R is false. So A is true and R is false. Okay, so option C is correct. Now question number 15, and an object is kept at a distance u in front of a spherical mirror. An image is formed at a distance v from the mirror. What is the magnification of the image? So magnification, by definition we know that magnification is minus v by u. So correct answer is option A. Okay. Question number 16. What is the position of the object placed on the side of reflecting surface of a concave mirror of focal length 15 cm if the image is formed at the distance 30 cm from the mirror? Okay, so focal length is 15 cm. Okay, and the final image is 30 cm. So as you can see, the final image, that is V, is basically 2f. V is 2f, means the final image is located at the center of curvature, right? 2f means center of curvature. So image is located at center of curvature. So what do we know? We know that if the image is at center of curvature, the object should also be at center of curvature. Yes, so that is the trick. So you don't need to do a mathematics for that. Okay, only thing you can directly answer 30 cm. Okay, so 30 cm will be the distance for the object as well. So because the image is 30 cm, that is twice that of the focal length, so image will also be 30 cm. If this is not the case, then you have to use the mirror equation to solve it. Since it is an MCQ and a basic simple questions like this might come and might be tricky for you, so you have to answer. We will see one more question is there, obviously, where similar concept is used. Okay, the question language is slightly different, so same question can be repackaged in a different way and can be presented to you. Now remember that from this chapter, obviously 25 marks question is not going to come. Okay, combining this chapter and human, I combine both chapters, there will be 13 marks question, I think, or so there you might face one such questions either as a form of MCQ or as a form of longer answer type of questions. Okay, so be prepared. Next, question number 17. Under which of the following conditions a concave mirror can form an image larger than the actual object? So a concave mirror can form an image larger than an object. There are two cases. Okay, when the object is obviously between focal length and the between center of curvature and focal length, okay, or it is closer than the focal length. Okay, so basically when the object is closer to C, when it less than C, the object distance is less than C, in that case always the image will be larger than that object. Okay, it can be virtual, it can be real, both is possible. So let's see what is the given option. When the object is kept at a distance equal to its radius of curvature, in this case image is exactly equals to its size, so it will not be the larger than the object. Okay, and the object is kept at a distance less than its focal length. Obviously this is a case where you obtain a larger than a virtual object. Okay, so this is a virtual object, but they have not mentioned whether it is a virtual or real. So this is obviously the case. When the object is placed between the focus and center of curvature, yes, focus and center of curvature also it produces a larger image. Okay, when the object is kept at a distance greater than its radius of curvature, in this case obviously it is not possible. So option B and option C both is possible. So there should be one more term, concave mirror can form an virtual image. Okay, virtual image larger than its actual subject. So in that case only option B will be the answer. Okay, so I hope that clarifies this question. Now let's move into the question number 18. Magnification produced by a rear view mirror fitted in the vehicle. So the magnification produced by a rear view mirror is always less than 1 because rear view mirrors are convex mirror. So we discussed yesterday day before yesterday's class that rear view mirrors are basically giving you a smaller images compared to the actual sizes. So that's why there is a caution written on top of the mirror that the distance might be the objects might be appear to be farther than actually they are. So they are actually closer than they might appear. So the less than 1 is the correct answer. Okay, now why do we prefer convex mirror as a rear view mirrors in cars? Okay, so let's see. A convex mirror has a greater field of view as compared to any other mirrors. Thus we can see a large area behind the car using a convex mirror. You can accompany that using a image as well. Okay, so you can accompany that using a mirror. So you can see that using a small mirror, okay, you can see a large portion of the area behind the mirror. Okay, if you are using a plain mirror, obviously the area will be much lesser compared to a convex mirror. Okay, and if you are using a concave mirror, it will be further less than that, and in fact it will not even produce a real image, not even produce a virtual image. So virtual image is very important because you are seeing that you don't have any screen to adjust. So basically it has to be a convex mirror or a plane mirror, but plane mirror has a less field of view, so convex mirror are preferred. Right. Now question number 20. A concave mirror produces 3 times magnified enlarged real image of an object placed at 10 centimeter in front of it. Where is the image located? So this question I discussed during our homework class, I remember, right? So what is the magnification? Magnification is m equals to minus v by u, and it is given as 3. Now why I am using negative sign? Because it is 3 times magnified real image. So for real image, obviously you have to use negative sign here. This negative sign cancels. Okay, so object placed at 30 centimeter in front of it, where the image located. So v will be equals to 3u. So in this case, u is minus 10 centimeter. U is always negative, so it will be minus 30 centimeter. So the image will be located 30 centimeter on the same side as the object. So you have to write this term compulsorily. If you don't write, they will deduct 1 mark. Okay, be careful about the answer. Now next question, question number 21. An object 5 centimeter high is placed at 10 centimeter from a convex mirror of radius of curvature 30 centimeters. Okay, so object height is given 5 centimeter. Let me write down all the given data. This is a long question, 3 marker question, so you have to write down all the data. Okay, 5 centimeter high is placed at 3 centimeter from a convex mirror. So mirror is convex of radius of curvature 30 centimeters. So convex mirror means focal length is positive, radius of curvature is positive. So focal length is r by 2, 15 centimeter. So focal length is 15 centimeter. Now find the nature, position and size of the image. So for each portion you will get 1 mark. Okay, for nature you will get 1 mark, for position you will get 1 mark, and the size of the image is you will get 1 mark. Now since this is a convex mirror, what will be the nature? So we know that convex mirror always produces real images. No? Yes, convex mirror always produces virtual images, real images. So convex mirror always produces virtual images. Don't trust me always, okay? So I might confuse you, I might try to confuse you, that is my job. But if you are very strong in your knowledge, then you should not get confused when I say real image, right? So convex mirror always produces virtual images. Okay, concave mirror can produce virtual image and can produce real image, both. Okay, so in this case, so nature is already sorted. So what we have to do, position and size of the image. So position, to find position, what we have to use? We have to use u is given. Okay, u is given minus 10 centimeter. Okay, u is always negative. For convex mirror, r and f are positive. So now we will use the mirror equation, 1 by v plus 1 by u equals to 1 by f. Okay, so what is 1 by v? You don't know. 1 by u is minus 1 by 10. sign is very important. If you are solving the numericals without using sign, then your answer will be wrong. So don't mess up with the sign. So my minus 1 by 10 will go other side, it will become plus 1 by 10 plus 1 by 15, right? So it will become, what is the LCM of 10 and 15? So it will be 30. So on this side it will be 3 plus 15 to the 32, so 5 by 30, so 1 by 6. So this is 1 by V, so V will be equals to 6 centimeter. So V is 6 centimeter. So the position of the image is 6 centimeter behind the mirror. Position, so nature, virtual, okay, position 6 centimeter behind the mirror, okay, and then we have to find the magnification. Magnification M is equal to minus V by U. So minus V is 6, U is 10, minus 10, so minus minus cancel, so 0.6. So this is the magnification. Now what is the original size? Original size was 5 centimeter, so the new size is H dash equals to H times M, that is 5 times 0.6, 5 6 is 30, so 3 centimeter. So height is, size is 3 centimeter, right? 3 centimeter. So this is the answer. If you write all these three correctly, you will get full 3 marks, and you have to show the accompanied calculations as well. Okay, so these are the 3 answers and these are the calculations. I hope you have understood this. These are very common questions. Now next is identify the spherical mirrors in the following cases. What are the cases? When the image is formed is virtual and erect in each case. So when image is formed is virtual and erect in every case. So when a mirror forms a virtual and erect in every case, definitely this is a convex mirror. Only one mirror that forms virtual and erect image every time, that is convex mirror. Object is placed between the mirror and its focus. Image is formed is enlarged and behind it. So we know that when a concave mirror is used and the object is between the focus and the mirror, so we get a enlarged virtual image behind it. So this is a concave mirror. Okay. Object is placed between the infinity and the device. Image formed is diminished and between the focus and the pole of the other side, that is that of the object. Okay, so in this case image is formed other side of the object. Okay, it is diminished and between the focus and the pole. Okay, so definitely they are talking about convex mirror. Okay, only in case of convex mirror we know that pole and focus is behind the mirror. So it is, if the object is here, image will be forming here, it is always diminished, right? So this is also a convex mirror. Okay, so if you have answered this 3 correctly, then you will get 3 marks. Very easy question, right? But little bit thinking style question. So if this question is combined with lens, then that will be a very good choice. Okay, they will give you some lens, some mirrors, so you have to identify them each time. Okay, now next question is a numerical question, 5 marks question. Study the data given below showing the focal length of 3 concave mirrors A, B and C and the respective distances of objects placed in front of the mirror. So case A, focal length is 20 centimeter, object distance is 45 meter. Case B, focal length is 15 centimeter, object distance is 30 centimeter. Okay, case C, focal length is 30, object distance is 20. So as you can see in this case, the object is beyond C, that is center of curvature, it is exactly at C, because if you see focal length and the distance is twice. Now in this case, as you can see, focal length is 30, object distance is 20, so it is less than F. Okay, it is less than F. These are the three conditions. As soon as you see this table, you have to write it down next to it. Now try to answer the questions one by one. In which cases the mirror will form a diminished image of the object? Justify your answer on marks 1. So obviously when the object is beyond C, or then only it will produce a diminished image. So only in case A, case 1, it will produce a diminished image, right, beyond C. So you have to mention that when the object is kept beyond C, in case of a concave mirror, it produces a diminished image. So in this case, case number 1, mirror number A, okay, the object distance is more than 2C, more than 2F, right? So the object is beyond C, so we can say the image will be diminished in this case. So this is the answer for question number 1. List 2 properties of image formed in case number 2. Okay, so in case number 2, we can see that focal length is 15 and the distance is exactly 2F. So the image is located exactly at C. So in this case, what is the 2 properties that we will write? 2 properties will be image is at C. So object is at C, image will be exactly at C. Image is exactly at C and of the same size of the object. Okay, what else you can write? It is a real image. Apart from that, one extra you can write, it is an inverted image. So these mainly these are the 3 properties. So first of all, it is located at C, so image will also be at C. Okay, secondly, it is a real image. Thirdly, it is a inverted image. Now third question, what is the nature and size of the image formed by mirror C? Draw the ray diagram to justify your answer. So in this case, as you know that the nature is obviously it is less than C, the nature is virtual, size is enlarged, okay, because it is between F and the pole. Now you have to draw a ray diagram for that. Okay, I am just giving you a brief how to draw the ray diagram. So here is the focus, here is the center of curvature. You can take the object here. Okay, then what are the rays I told you? One parallel passing through the focus, another is passing through the center of curvature, and they will not intersect here, they will intersect behind, and after this you will get the image, right? So this is the virtual image. I need a little bit more space to draw this diagram, that's it. Okay, let me draw it, try and draw this here quickly. So this is F, this is C, this is my object. First is this, next is this. Okay, so in this case, if you draw this, if you extend this in the behind, after some time they will intersect. Try to keep it close to the focus, that will help. So this is a virtual image, upright image, and obviously enlarged. Okay, so these are the things that you can draw, explain from the ray diagram. Okay, so the ray diagram that you have to draw, I have already told you the tricks to draw a ray diagram. For this case, you can try to keep the object as close as the focus but slightly less than the focal length. Okay, that will give you a clear picture. Okay, now the last question, the case based question. A student focused an image of a candle flame on a white screen using a concave mirror. He noted down the position of the candle screen and the mirror as under: position of the candle equals to 10 centimeter, position of the mirror equals to 50 centimeter, position of the screen 10 centimeter. Now what is the focal length of the concave mirror? 2 marks. Where will the image be formed if he shifts the candle towards the mirror at a position of 30 centimeter? Question number 3, what will be the nature of the image formed if he further shifts the candle towards the mirror? Okay, these are the 3 questions. First question, as you can see, the position of the candle and position of the mirror are both same. Okay, so we can see that position of the candle and position of the screen are same. So basically it representing the position where you are placing the object at 2f distance. So I told you that this is a very good example. So they have just changed the language. Okay, they have just changed the language to make you understand that basically because candle and screen are at the same position, that means only one case candle and screen can be at the same position. That is when the object is kept exactly at the center of curvature. So we can see that what is the u here? U here is 50 minus 10, that is 40 centimeter. What is V here? V is 50 minus 10, that is also 40 centimeter. Sign I am ignoring right now, so only the magnitude we are calculating. Okay, so in this case we can see that both image and object distances are same, so we can say this is exactly the 2f. So 2f equals to 40 or f equals to 20 centimeter. So the focal length of the concave mirror is 20 centimeter. So if you answer that, you get 2 marks. Very easy. Next is whether where will the image be formed if he shifts the candle towards the mirror at a position of 30 centimeter. If he shifts the candle at a 30 centimeter distance, then what will be u? U will be equals to 50 minus 30, that is 20 centimeter. So what is this? This is exactly equals to f, right? We already calculated f. So what happens when we keep an object in front of focus, exactly at focus? Obviously the image will be formed at infinity. Okay, so image will be formed at infinity. So this is the answer for this. Image will be formed exactly at infinity. Okay, what will be the nature of the image formed if he further shifts the candle towards the mirror? So as the distance is less than f now, the nature of the image will be virtual and enlarged. Virtual, erect and enlarged. Okay, virtual is the answer. These two are the optional. You can write that. Your teacher will be impressed if he sees, okay, the student knows, the understand the concept. So definitely I will try to give him the maximum possible marks. So this is the main thing. Virtual is compulsory to write. Right now, if you are wondering what to do after your class 10th is over and what should be your future goal, you should prepare for a doctor, to become a doctor, or you should prepare for to become an engineer, or you should study science at all. So Diksha is presenting Diksha Scholastic Aptitude Test, that is DSAT. It is getting conducted at Diksha campuses across all the Diksha campuses every Sunday, and the seats are limited. So if you are still in the confusion state, talk to your parents, fill up this form and join the DSAT test immediately. Here there will be a 60-minute class. Okay, their teacher will teach you based on some concepts, and after the class is over there will be a one-on-one doubt clearing session, 15 minutes doubt clearing session. Once the doubt clearing session is over, then there will be a 60-minute test based on the class that was conducted. Okay, after after your test results are out, then there will be a clear indication that which stream best suited for you, and based on that there will be a one-on-one counseling. Okay, one-on-one counseling. And if you are still want to participate in that, and to avoid this confusion, you can fill up this form, talk to your parents, fill up this form, and our representative will contact you. And tomorrow there will be a class on refraction, so don't miss out on that. And if you liked our classes, don't forget to like, share and subscribe to our channel. I'll be back with refraction tomorrow. Till then, bye.